this lesson, we will discuss how ionic bonds make compounds. Atoms are the basic unit of matter. Remember that the protons and neutrons are tightly bound inside the nucleus. The electrons orbit the nucleus in the electron cloud. These electrons are what determine the reactivity of the atom, its ability to interact with other atoms to form compounds. When atoms join together to form compounds, it is called bonding. Compounds can have very different properties from their component elements. For example, sodium is a metal. It reacts violently with water. Chlorine is actually a poisonous gas that has a greenish-yellow color. If you combine these two elements, you get the compound sodium chloride, which is actually just table salt, something that we sprinkle on our food just about every day. So you can see how the compound sodium chloride has very different properties from sodium metal and chlorine gas. An atom's ability to bond with other atoms is determined by the number of electrons in the outermost orbital. All atoms want their outermost orbital to be full. Think of the orbitals filling up with electrons like a tiered fountain fills up with water. Remember that the first orbital can hold 2 electrons. Any additional electrons overflow to the second orbital, which can hold 8. Any additional electrons after that overflow to the third orbital, which can hold 18. Remember that all atoms want to have their outermost orbital full of electrons. If the first orbital happens to be the outermost, then the atom will be happy having 2 electrons in that energy level. If the outermost orbital happens to be the second orbital, then 8 electrons would make that atom happy. If the outermost orbital is the third orbital, the atom will be happy having either 8 electrons or 18 electrons in that energy level. Let's examine how ionic bonding occurs using our previous example of sodium and chlorine bonding to make sodium chloride, or table salt. A sodium atom has 11 protons in its nucleus and 11 electrons orbiting in the electron cloud, 2 in the first orbital, 8 in the second orbital, and 1 in the third orbital. Because sodium has the same number of protons and electrons, it carries no charge. It is called a neutral atom. But just because sodium is neutral doesn't make it happy. At the moment, sodium's outermost orbital is the third orbital. This orbital can be considered full, holding 8 electrons or 18 electrons. Sodium only has 1 electron in that outermost orbital. That means that sodium could go around begging for 7 more electrons to fill that third energy level, or it could lose 1 electron to make the second orbital its outermost orbital, and then it could be considered full, having those 8 electrons. This is where chlorine comes in. Chlorine has 17 protons in its nucleus, and 17 electrons orbiting in the electron cloud. It is therefore a neutral atom. Chlorine's outermost orbital is also the third orbital. It has 1, 2, 3, 4, 5, 6, 7 electrons in that energy level, but it needs 8 to be considered full and for chlorine to be happy. These two atoms are going to help each other out. Sodium is going to take its extra electron and transfer it to chlorine. Now these two atoms both have outer energy levels that are full. Sodium is now happy, and chlorine is now happy. After the electron transfer, these atoms are no longer considered neutral. Remember that sodium has 11 protons in its nucleus. It used to have 11 electrons balancing out those positive charges, but it gave 1 electron away. So now it only has 10 electrons in the electron cloud. This means that it has one more proton than it has electrons. This gives it a +1 charge, and this sodium atom is now called a sodium ion. Chlorine has 17 protons in its nucleus. After receiving an electron from sodium, it now has 18 electrons in its electron cloud. This means that it has one more electron than it has protons. So chlorine now has a negative charge and is also called an ion. We all know that opposites attract. Because these two ions have opposite charges, sodium with a positive charge and chlorine with a negative charge, they're going to be attracted to each other and form an ionic bond. The attraction between two oppositely charged ions is what gives ionic bonding its name. The oppositely charged sodium and chlorine ions attract each other in a crystalline structure that gives us salt crystals. It's funny to imagine that all of that electron activity happens in order to give us something so common as table salt. Ionic bonding can occur between more than just two atoms. Magnesium is an atom that has 12 protons in its nucleus and 12 electrons orbiting in its electron cloud. Fluorine has 9 protons in its nucleus and 9 electrons orbiting in its electron cloud. Right now, these atoms are neutral because they have the same number of protons in their nuclei as they have electrons orbiting in the electron cloud. They won't be happy, however, until their outermost orbital is full. In order to accomplish this, magnesium will transfer one electron to each of the nearby fluorine atoms, giving magnesium a +2 charge, since it lost 2 negatively charged electrons, and each fluorine atom a negative charge, since they each gained a negatively charged electron. These oppositely charged ions will now attract each other in a crystal called magnesium fluoride. As you saw in this lesson, ionic bonding involves the transfer of electrons from one atom to another. Another type of bonding, called covalent bonding, which you'll learn about in the next lesson, involves the sharing of electrons between atoms. Regardless of whether bonds are ionic or covalent, when a chemical reaction occurs, the atoms in the compounds get rearranged. This means that the bonds in your starting materials are broken down to form the bonds in the product materials.